Hello everyone, welcome to this lecture of the course Digital Electronics, and in this lecture we will be talking about NOR gate as a universal gate. If you recall, in the previous lecture we spoke about basic gates and two universal gates. I explained why NAND and NOR are called as universal gates, and we further looked into basic gates and OR and NOT, and we realized those gates. We formed the operationality of those three gates using a NAND gate. In this particular lecture, we will obtain or we will form three gates, three basic gates: AND gate, OR gate, and NOT gate using our OR gate, using an OR gate, right? So basically, let's start with NOT gate. So in NOT gate, we simply want output is not of input, right? And we know that our NOR gate is nothing but this is not of OR, correct, which is equal to a bar dot b bar using a De Morgan's law. So let's keep this property in our mind that NOR gate is a plus b whole bar, which is a bar dot b bar. Now if we have to realize a NOT gate is the easiest one because eventually we can always write C is not of a as C is not of a plus a. We have already looked at Boolean expression laws, and a plus a is always equal to a, right? So basically if I supply one input of a NOR gate as, if I compare these two expressions, right? If I assume A is equal to A and B is equal to A, I would be able to get a operationality of a NOT gate using a NOR gate. This would simply mean that if I have a NOR gate like this with two inputs, and both the inputs I supply as an input A, my output will be A bar, because this will be A, this will be A, so A plus A whole bar would be equal to A bar, correct? In this way we have realized a NOT gate as functionality of as function of NOR gate, right? Moving ahead, now if we have to realize a combination of AND gate as a function of NOR gate. AND gate is what? In C is equal to A and B is AND gate, and a NOR gate for me is nothing but A plus B whole bar, which is equal to A bar dot B bar. So basically if I compare these two, right, what do I see? If I have to obtain AND gate using NOR gates, what I have to do is I have to simply take a reverse of A and AND it, which would be like I would obtain A bar from A, B bar from B, and then what we will do, we will do a NOR of those two together, correct? So basically this would be equal to something like this. I have a gate, I put a NOR gate over here, this is A. Similarly, I say this is B. It's a NOR gate, so this will be A bar, B bar, right? Now if I supply these two inputs to a NOR gate again, what will be my output over here? A bar plus B bar whole bar, which is nothing but A bar whole bar dot B bar whole bar, A dot B. This is NOR gate. This is what we have obtained is using three NOR gates we have obtained a functionality of AND gate. And similarly, if we have to look at OR gate, right? If we have OR gate functionality is something like A plus B, and NOR gate is something like A plus B whole bar. So basically what we can do is we can simply pass A and B. We can simply pass A and B through a NOR operation, and then we can reverse it. So basically this would be equal to nothing but A plus B bar whole bar, correct? So basically we can obtain this functionality using an OR gate straightforward. A, B, this will become A plus B whole bar. Sorry, this will be NOR, yeah, NOR operation. And then what we have to do is we have to pass through a NOT gate. And as we have already seen, NOR operation as a NOT gate could be something very simple like this. This will be A plus B. So this, by this we have realized AND gate, sorry, OR gate as a function of NOR gate. Like we said in the previous lecture as well, and, not, and or are basic gates, and they can be used to realize any Boolean expression. And now, since all these three gates we have been able to form using a combination of NOR gate, we can say any Boolean expression could be realized only using NOR gates, and hence NOR gate is also known as a universal gate. I hope you liked this particular lecture and all these examples we solved. Stay tuned for the next lecture.